Hey guys, today we're going to cover notes 5.4, centers of triangles, circumcenter. For circumcenter, the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. The circumcenter is equidistant from the vertices of the. So let's go ahead and list the perpendicular bisectors. So again, those are the ones that go down to the sides of the triangle, creating two congruent segments. So if you can see this, and this, they are all perpendicular bisectors. They all bisect the side, creating two congruent segments. So we have PF, PE, and PD are all our perpendicular bisectors. They all come together at the circumcenter, which is point P. So now we're going to list our congruent segments. I see that AF is congruent to FC. CE is congruent to EB. I see that BD is congruent to DA. And then pay very close attention to that second statement where it talked about the circumcenter is equidistant to the vertices of the triangle. The vertices are the corners. So from point P all the way down to the vertex, point B, that's the same distance as from P to A, which is also the same distance as P to C. So those three segments would be congruent as well. So we can say PB is congruent to segment BA, which is congruent to segment PC. Here on number 1, it tells us that Z is the circumcenter of triangle TUV, so we need to find all the missing measures. The first one we need to find is TU. What is the length from T to U? So what I'm going to do is I'm going to go ahead and label all my segments that are congruent. So I can see that from T to X, it's also 19 because those two are the same length. Therefore, if I add them together, it gives me TU, which is VY would just be half. And the length from U to Z, remember that goes from the circumcenter down to the vertex to the corner. So that's the same as the other three. And if you notice, it actually gives you one of them. It's 21. Therefore, UZ is also 21. To find the length from W to V, you're going to have to use Pythagorean theorem. Remember that our perpendicular bisectors form a right angle. So I'm going to focus on this triangle where I have 15 and 21, and I'm going to redraw the triangle so you can see it. So all that really matters here is that you make 21 the hypotenuse. So I have my A, my B, and my C on a right triangle. Your C is always your hypotenuse, and that's always across from the 90 degrees. So 21, I have to make sure that I know it's my C. For Pythagorean theorem, it's A squared plus B squared equals C squared. And again, we use this when we're trying to find a third side, and you know two of the sides of a triangle. So for part D, I can take 15 and square it plus B squared equals 21 squared. So I'm trying to find my B. I get 225 for 15 squared and 441 for 21 squared. So now I'm going to subtract. And I get 216. Now to get rid of that exponent, the inverse operation is to take the square root. The square root and a squared cancel out. So you're just left with B equals, and the square root of 216 is around 14.7. What we want to do is we're going to round to one decimal place, to the nearest tenths place. So if the length from V to W is 14.7, then I can find E because that's TV. TV is the whole thing, the whole side of this triangle. So I can just take 14.7 and multiply it by 2. So you get 29.4. All right, so again, quick review on Pythagorean theorem. I should have done that earlier. So you have your A, your B, and your C. Your A and your B are your legs. That's what makes up the right angle. And again, your C is always your hypotenuse. That's always across from the 90 degrees. And to solve for a missing side, just remember your formula, A squared plus B squared equals C squared. So that always helps you find the third side if you know two of your other sides. And also remember that this only works specifically for right triangles. You can't do this if it's not a right triangle. You can't use Pythagorean theorem unless it's a right triangle. All right, for number 2, we also have a circumcenter. So the first thing I need to do is find the length from G to D. I'm going to go ahead and. All right, well, the length from G to D is half of 24. So I get from G to D, it's 12. The length from B to C, I just double the 7. Then I have the length from E to H. So that's actually not congruent to anything, so it looks like I'm going to have to use Pythagorean theorem. So I kind of outlined, I highlighted the right triangle. One of my legs is 7, so we can say that that's my a squared. I'm trying to find from E to H, so I don't know what b squared is. I'm trying to find my b. And I know what this is, my c squared. That's the same length as from b to h. So that's 13. So I can take 7 squared plus b squared and set it equal to 13 squared. So I get b squared is 120. And when I take the square root of that, you should get 11. And if it seems too complicated to try to picture the right triangle, remember that you can always go off to the side of your paper or get some scratch paper and just kind of redraw the triangle so that you don't get your C confused with your A and B, because it's important that you know what your hypotenuse is. All right, for part D, I'm trying to find the length from F to D. I tried to look at CF, but it actually doesn't give me anything. So I don't have anything to go off of, so it looks like I'm going to have to use Pythagorean theorem on this triangle. So you're going to have to do your a squared plus b squared again. And remember that your C is still 13. So I get b squared is 160. So when I take the square root of that, I get b equals 12.6. And for part E, I need to find the length from C to D. So I know that from F to D, it's 12.6 because I just found that. So if I multiply that by 2, I get the whole length. So you get 25 points. All right, for number 3, I'm also dealing with a circumcenter, so I'm going to go ahead and label all my congruent segments. So the first thing I want to find is GI, the length from G to I. So I know that if half of it is 30, then the whole thing will be 60 because I just double it. Next, I need to find MH. Well, MH is the same length as MI and MG. Remember that the segments that go to your corners, the vertices, are all the same length. But unfortunately, it doesn't give me the other two lengths. So it looks like I'm going to have to use Pythagorean theorem to find that. So there is my triangle. Just remember, again, make sure that you know what your A, B, and C are. I went ahead and drew the triangle again here at the bottom if you want to look at that, if looking at the whole picture is too confusing. Remember that if GJ is 31, so is JH. So I have 31 and I have 14, and I'm trying to find my hypotenuse, my C. So I get 34 for MH. So remember how we just said that MH is the same as MG? Well, part E, I noticed that it's asking us for MG, so it's also going to be 34. All right, so for part C, I need to find IK. IK is this length here. Now I could look at KH, but it doesn't give it to me, so I have to use Pythagorean theorem again. So I'm going to go ahead and highlight the triangle that I'm going to use. So I can see that one of my legs is 23. I know that this length is 34, and I'm trying to find one of my other legs. I get b squared is 627, and so finally I take the square root of that, and I get x equals 25, or b equals 25. And the last thing it wants me to find is the length from I to h. So I know that half of it was 25, therefore double it, and you get 50. Okay, next we're going to talk about incenter. The angle bisectors of the angles of a triangle intersect at a point called the incenter. The incenter is always equidistant from the. So my angle bisectors are the ones that make two congruent angles. So I have PA is one, PB is another, and PC is the third one. They all intersect. If you remember from the previous lesson where we talked about angle bisectors, if we focus on these two triangles here, okay, where we just have one bisector, then we know that these two sides would be congruent, and therefore the sides that are on opposite sides of each other are also congruent. So DB is congruent to BE. The same thing applies to the other sets of triangles. So EC is congruent to FC. And DA. Also, if you remember from the second statement, the incenter is always equidistant from the sides. So those three sides, which I've already labeled, those are all congruent as well. So we can say DP is congruent to PF, which is congruent to P. All right, so number one, it tells us that P is the incenter of this triangle. The first thing we need to find is NP. So the length from N to P is 8 because that's the same as M to P, which is also the same as P to O. So now I can see that the length from N to K is 17 because it's the same as from O to K. For part C, PK isn't congruent to anything, therefore it looks like I'm going to have to use Pythagoras. So I have 17 squared plus 8 squared equals C squared. I'm trying to find my C. And I get 18.8. And the last thing I need to find is the length of LO. So LO is that right there. It looks like we're going to have to use Pythagorean theorem. So the reason that we have to use Pythagorean theorem here is because LO is congruent to ML, but it doesn't give us the length of ML. So we're forced to use Pythagorean theorem. So when we set this up, we're going to say 8 squared because that's one of my legs. I'm trying to find the other leg. So that's my B squared. My hypotenuse is my 13. So I get 10.2 for the length of LO. All right, for number 2, we're still dealing with an incenter. I need to find the length of GD. So GD is this one here. And I'm going to look to see if any of the other lengths are given that it's congruent to. And unfortunately, it doesn't give us the length, so we're going to have to use Pythagorean theorem. So I can say 35 squared plus my B squared, that's what I'm trying to find, equals. So the length of GD is 12. Next, I need to find B. So that length is also not congruent to anything else. So I'm going to use Pythagorean theorem, and here's my triangle, because that's the triangle that has BG. So I have 6 squared plus 12 squared, because EG is 12, since it's the same as GD, and that equals C squared. I'm trying to find my hypotenuse. All right, so I get 13.4. Now I need to find the length from F to C. Well, remember that that is the same as the length from D to C, so it's also 35. And then I need to find BF. BF is the same as BE, therefore it's 6. All right, number 3 is a little different. It says that if S is the incenter of triangle PQR, the measure of angle PRQ is this whole angle down here. That's 8x minus 10. And the measure of angle RPQ, that's this over here, that's 4x minus 14. And PQR, which is this third one over here, that's 7x minus 5. So I need to find each missing measure. The first thing I need to do is find my x, because I can't find any measures if I don't know what x is. So if you go back to a previous lesson that we've done in the past where the sum of the angles of a triangle is 180, then you know how you can set up your equation. Add them all up and set them equal to 180. So now what I'm going to do is I'm going to go ahead and plug my x into those 3 angles that I have already shown on the picture. So those are actually my first 3 angles. I have part A is 78 degrees, part B is 30 degrees, and part C is 72 degrees. And part D wants us to find the measure of angle RPS. Well, RPS is right here. So that's half of 30. It's 15 degrees. I know it's half because remember we have an angle bisector right here. PS is an angle bisector. So that means this is 15, I'm sorry. So angle PQS, that's over here. So again, I know the whole thing is 72, so PQS is only half of that. So I get 36. And angle PRS is over here. So that's half of 78, so I get 39 degrees. And the last one, angle PSR. PSR is this angle right over here. So I already know that this one is 15 degrees and this one is 39 degrees. Remember that the sum of the angles for a triangle is 180. So if I add those two up, 39 and 15, subtract from 180, I get the third side, which gives me 126.